Okay. Whoops, I forgot to copy the original problem down here to make it bigger. All right, you are solving an absolute value equation. And to do that, you have to get this part by itself. But right now there's that -2 that's, multiplied in front here. So I'm going to have to divide both sides of the inequality, inequality, by -2, because then -2 over -2 makes that a 1 times all that stuff. So you're just left with all that stuff, the absolute value of a k minus 4. But since I divided by a negative, I have to switch that from less than to greater than or equal to, and I get a 3. At this point, you have to realize that there's going to be 2 possible values for k, that when you plug it in there, subtract it from 4 and take the absolute value, it could give you a 3 or it could give you a -3. So when you do this part, you have to split it into 2 equations. I start with just the k minus 4 is greater than or equal to 3. But then you have to consider the other possibility of k minus 4 being less than or equal to -3. Remember that inequality, or the last problem we did, we had that number line, and it was, you were at the 4 and they wanted to know how far you were to the right with 9 and how far to the left you were with 9, and 4 and 9, what was this? This was 13 and this was -5, but you are moving 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right, or 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. So you either ended +9 to the right, or you went 9 to the left, which would be like a negative move. It's like subtracting 9. So you have to consider, let me get another color here. You have to consider like going this way for this particular problem, the 3, but then going this way in the opposite direction, the -3. I know I drew one for 9 because I was, just kind of trying to relate it to the previous problem we did. You're going to the right, you're going to the left. But when you go to the right, that's 3, and it's in the greater than direction. When you go to the left, that would be like subtraction of 3, but you're going in the less than direction. You're switching directions. Okay, anyway, you have to switch them. So not only are you switching, like when you do it the first time, you're taking this inequality sign and the 3, okay? You're dropping the absolute value signs. But then you have to consider the other situation, which is less than or equal to the opposite of 3, which would be -3. And now we just solve both equations. And to solve it, you're simply adding 4 on both sides. So one of these is going to be k is greater than or equal to 7. And the other one, when I add 4 to it, I get k is less than or equal to, -3 plus 4 would be a +1. Okay, now, if you were to graph this, somewhere down here is 1, somewhere up here is 7, right? For the blue one, when I do k is greater than or equal to 7, I would have a bracket here and I would be highlighting to the right. For the green one, I would have x is less than or equal to 1, so I'd have a bracket here but going to the left. These two do not overlap each other at all. So this is an OR situation. it's two separate intervals. So for the green one, let me switch it to a much thinner pen if I can. It's as thin as I can get. For the green graph, as an interval, it would be from negative infinity up to the 1 and include the 1. And then for the blue one, it would be starting at 7 and then going to positive infinity. And then this says right here, to enter infinity, type the word infinity. To enter a union, type a capital U. So you're going to put a capital U here. All right, so let's jump back to Mobius. And this is going to be negative infinity, comma 1 bracket. And then a capital U, and then bracket 7, comma INFINITY. And if I haven't said it before, infinities always get parentheses because technically we never get to infinity. You just keep going. And I don't care what Buzz Lightyear says, you know, that whole to infinity and beyond. Nobody's ever been to infinity, so you can't get beyond it. But anyway, how did I do? Yay! I got it right.